we're going to be starting Unit 2, and we're going to be starting Unit 2 with exponents and perfect squares. Let's go ahead and get started right now. So we have to start with a few key ideas about exponents. Exponents are a shortcut for repeated multiplication. So anytime that you're using an exponent, it's like multiplying the number over and over and over again. So 6 to the third would be 6 times 6 times 6, but rather than writing that all out, we do 6 to the third. Now we need to talk about the vocabulary terms that come along with exponents. So we have two parts of our exponents. We have the power, and then we have the base. So the base is raised to a power, and that is the number that we are going to multiply that number of times that the power indicates. A couple of odd one-off rules, though, are any number to the 0 power is 1. So, for example, 8 to the 0 power is 1. 10 to the 0 power is 1. 1 million to the 0 power is 1. And any number to the first power, like we have here 6 to the first power, is itself. So, for example, 6 to the first power is 6. Let's take a look at example A. Here we are at example A, and you can see that we have several numbers that have been raised to exponents. First, we're going to show their expanded form, and then we're going to show what that looks like simplified. So the first thing I've got is 4 squared. So when I got 4 squared, that really just means 4 times 4. And if I do 4 times 4, I get 16. So I'm going to go ahead and drag 16 into place, because that's my simplified form. The next one I've got negative 7 to the third power. So that's really just negative 7 times negative 7 times negative 7. So I'm going to do negative 7 times negative 7 times negative 7, and I end up with negative 343 as my simplified form. Same thing with 5 to the third power. I've got 5 times 5 times 5, and if I simplify that, 5 times 5 is 25. 25 times 5 is 125, so there's my simplified form. Then I've got negative 1 to the 5th power, so that's going to be negative 1 times negative 1 times negative 1 times negative 1, 5 times. So if I simplify that out, I've got a negative times a negative is a positive, positive times a negative is a negative, negative times a negative is a positive, and then positive times a negative is a negative. So I end up with negative 1. So notice for my expanded form, I've taken each of my numbers and I've written out how many times this needs to be multiplied. And then the simplified form is when I have just one number when I've done my multiplication. So now let's try some practice problems on your own. Here we are at practice number 1. You've got 4 problems that are try on your own. Make sure that you have the expanded forms for the ones that need them and simplified forms for all of them. Careful, there are a couple tricky ones down there at the bottom. I want you to go ahead and pause the video now, try these problems on your own, then press play again to see if you are right. Okay, how did you do? Were you able to get the answers that I got? Make sure your paper looks like mine if you didn't. Make sure that with anything to the 0 power, the answer is 1, and anything to the first power is itself. So 34 to the 0 power is 1, 78 to the first power is 78. Now let's move on to some key ideas about square roots. Okay, so when talking about squares and square roots, the first thing we need to remember is a number squared is a number times itself. What does square root mean? Well, when we're talking about a square root, we mean that any number which when multiplied by itself equals the number that was given. And a perfect square is a whole number whose square root is an integer. Okay, again, integers can't have fractions, they can't have decimals, but they could be positives or negatives. Now let's take a look at some perfect squares. Here is a list of all the perfect squares 1 to 20. Now, the key is in 7th grade that you have to memorize this list. And unfortunately, that's just the way that it is. It's not that bad. Some of them you probably already know up to 10, maybe even to 12. But the key is going to be memorizing those 13 through 20. It's not my idea to have you guys memorize them, but it is what it is. So here is a list for you to reference and memorize them from. Now let's go ahead and take a look at them put into practice. So here at example B, I've got several numbers down my left-hand side, and I'm going to determine what the square root is and is it a perfect square. So 16, what is the square root of 16? 4 times 4 is 16, so I know my square root is 4. And is it a perfect square? I don't see any fractions, I don't see any decimals there, so it is an integer, so yes, it is a perfect square. All right, now 60, I don't have any number that I can think of off the top of my head. 7 times 7 is 49. 8 times 8 is 64, so that's going to fall somewhere in the middle, so probably 7.64 something. I don't have a calculator, so I can't write exactly what it's going to be. So it's going to be 7.7 something. I'm not sure, but I know that is not a perfect square, because if it's got decimals there, which it's going to have, it's not going to be a perfect square. 289, is that a perfect square? Yes, it's 17. 17 times 17 is 89, so I'm going to say yes there. And is 361 a perfect square? It may appear as though it doesn't, and this is why you have to memorize them, because the square root of 361 is 19. Okay, so 19 times 19 will give you 361, so yes, it is also a perfect square. Now let's have you try some on your own. Here we are at practice problem number 2, and it's got 4 problems for you to try there on your own. You're going to figure out what the square root is. If you really need help, you can go back and take a look at that list, but try and do it on your own without the list. I want you to pause the video now, try the problems on your own, and then press play again to see if you are right. Okay, how did you do? Were you able to get the answers that I got? Notice that all of them are perfect squares. 0 times 0 is 0. Hopefully we knew that one. The other ones were all on the list. Make sure that your paper looks like mine if it doesn't. That brings us to the end of this video. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.